Hello everyone, this is Maushmi and today I am back with some more question and answer sessions on vectors. So let's begin. The first problem, if a vector has an x component of minus 25 units and a y component of minus 40 units, the magnitude and direction of this vector is. So we need to find out the magnitude and direction of a particular vector. Suppose we assume that vector to be vector r. So vector r has got both x and y components. Let's give its x component as rx, the direction of the vector given by the unit vector I cap, plus we have ry as the y component of the vector, and the unit vector in that particular direction is given by j cap. So we already have the x and y components given as minus 25 units and minus 40 units, or we can say we have rx is equal to minus 25 units and ry equals minus 40 units. Now we need to find out the magnitude and direction of this particular vector. So the magnitude is given as modulus of vector r, which is nothing but square root over rx square plus ry square. Now we just need to put in the values. We have rx as equal to minus 25 and whole square of that, plus ry as minus 40 and whole square of that. So as a result we get the magnitude of vector r as equal to, if we calculate this out, we get this as equal to 5 root 89 units. So you can very well see this. We have this as root over, this is 625 plus this is 1600. So sum of the two, it's 25. So it's square root over 2225. So if you imagine 25 coming out from here, then it becomes root 89 and root over 25 is 5. So we get this as 5 root 89 units. Now to find out the direction of this vector, as we have been using the tan component to find out the direction, let's proceed in that manner. We have tan theta as equal to ry by rx. So ry is equal to minus 40 and rx is minus 25. So if we see this, it comes out to be minus, this is minus 8 and this is minus 5. So just imagine this as a right angle triangle. So tan theta is nothing but perpendicular by base. So minus 8 is the perpendicular and minus 5 the base. So we have the hypotenuse as root over minus 8 square plus minus 5 square, which is nothing but root 89. So you can see this, we have this as perpendicular by base, that is theta equals tan inverse of minus 8 by minus 5. That could be one of the answers, but as we look at the options, we see no answer with the tan component. So what we are to do in this case? Now tan theta is equal to perpendicular by base, so we can proceed with any other trigonometrical ratio. So just imagine it as cos. Since we can see that we have the first option common for the options A and B, which tells us that the answer has to be either in sine or cos. So let's think about cos initially. So we have cos theta as equal to base by hypotenuse. So look at the triangle. We have the base as minus 5 and the hypotenuse as root over 89. So you can very well see that theta is equal to cos inverse of minus 5 by root 89. So this tells us that option B stands correct. Now proceeding to the next problem, a force of 10 Newton is resolved into the perpendicular components. If the first component makes 30 degree with the force, the magnitudes of the components are. So let's try to see this or visualize this. We have a force of 10 Newton which is resolved into two rectangular components. So these are the rectangular components and this is our force F equals 10 Newton, the net force. It is resolved into perpendicular components and the first component, say it be F1, it is making an angle of 30 degree with the force. So suppose this is the first component F1 which is making an angle of 30 degree with the resultant force, and the second component is given by F2 which is making an angle of, you can very well see, 90 minus 30, that is 60 degree with the resultant force. So if you try to analyze the components, you can very well see that, try to complete this triangle and you can see that if you want F1, F1 is nothing but F cos theta. Since cos theta is base by hypotenuse, so cos 30 degree is equal to base, that is F1, by hypotenuse, that is F. So what we have here is actually cos 30 degree equal base, that is F1, by hypotenuse F. So you can see from here that F1 is nothing but F cos 30 degree. So let's put in the values. F is 10 and cos 30 is nothing but root 3 by 2. So this is cos 30 which gives us a value of 5 root 3. So this is the first component F1, 5 root 3 in Newton, since the force is given in SI units, that is Newton. Now similarly, if we look at F2, we can very well see that F2 is equal to F sin theta. Try to complete this right angle triangle. You can see that if you compare the right angle triangle, then F2 will give you sine of the angle. So we have F2 is equal to F sine 30 degree. So this is 10 for F and sine 30 is half. So we have F2 as equal to 5 Newton. So look at the two components now. The X or the first component is 5 root 3 Newtons and the second component is 5 Newton. So you can see that the option C stands correct. Now proceeding to the next problem. Two billiard balls are moving on a table and the component velocities along the length and breadth are 5,5 meter per second for one ball and 2 root 3 2 meter per second for the other ball. The angle between the motion of balls is, so let us visualize this pictorially. We have two billiard balls which are moving on the table and their component velocities are suppose given as V1 and V2. So let us look at the diagram. The component velocities, suppose this is V1, making an angle, some angle with the horizontal, and this is the other component of velocity, say V2. Now look at these two vectors. These are the two velocity components. Now the first one, suppose it makes an angle of theta 1 with the horizontal, while V2 is making an angle of theta 2 with the horizontal. So how can we write these, or how can we use the parameters that have been given here to represent the vectors? So for one of the balls, what we can write is that the components are 5, 5. So you can write V1 as equal to 5 I cap plus 5 j cap. And for the other ball, what you can do is you can write V2 as equal to the two components, that is 2 root 3 I cap plus 2 j cap. So this is what we have for the two components. Now we need to find out the angle between the motion of the balls, that is we need to find out the angle between the vectors in fact. So let's go for theta 1 and theta 2 first, and then we shall find out the angle between the motion of the balls. So for theta 1, it is tan theta 1 again. Tan theta 1 is equal to y by x. So we have y as 5 and x also as 5. So this is 1, which gives us theta 1 as equal to 45 degree, since tan 45 is equal to 1. Now for the second part, let's look at tan theta 2, y by x again, we have 2 by 2 root 3. So this is equal to 1 by root 3, and theta 2 will be equal to 30 degree, since tan of 30 degree is equal to 1 by root 3. So we have theta 1 as 45 degree and theta 2 as 30 degree. So the angle between motion of the balls is nothing but theta 1 minus theta 2. That is the difference between the two individual angles that the vectors make with the horizontal. So we have this as 45 degree minus 30 degree, which is equal to 15 degree. So we see that option D stands correct.